Hello, Professor Correa. This is my exam demonstration 2. So for the first question, I fixed question number 5 on exam 2, where I did not reflect by the y-axis. Instead, I reflected by the x-axis here. So I redid it down here, and this is the graph reflecting over the y-axis, and the vertical asymptote here, sorry, is -4. And then the domain becomes negative infinity to -4. And then the range is negative infinity to infinity. So that's what this graph represents. In question number 2, we needed to create an exponential function using the horizontal asymptote y=3 and the range negative infinity to 3. So I came up with the function f of x equals negative e to the x exponent plus 3, because we have a 3 at the horizontal asymptote, and then the negative e reflects over the x-axis. So I thought it would probably go a little bit like this and then come near, but not passing the 3 horizontal asymptote. For question number 3, we were given kind of a word, or not, it wasn't a word problem, but basically finding out the t in seconds and the height, or in feet, of the motion of a ball. So we were given this equation in standard form, and then we changed it to be in this form. So how I did that was using this, using the standard form and kind of mapping out the different parts of this form. So for A, once we start with A, then we're able to get all the other different components, H and K. So that's what this shows here. So for this equation, I got HT equals -16 t minus 1.5 to the power of 2 plus 324. The vertex we know is H and K, H being the 1.5 and the K being 325. And then since it's in A is negative, we know that the parabola opens down. And so using the x-intercept, or using putting the x's, or the part in the parentheses equal to 0. Oh, yeah, equal to 0. Sorry. I don't know why I'm confused. Okay, well, so putting the equation equal to 0, I was able to get the x-intercepts, which are reflected here, -3 and 6. And then by switching out the x and y and putting the x equal to 0, I was able to get the y-intercept, which would reflect the maximum height, which is 288, which isn't super reflected on this parabola, but I thought it looked nice. But 288 feet is the maximum height that I got for the maximum height that the ball goes up. And then when it hits the ground, it's going to be in a positive. So I only, kept where the x and y are positive, and it hits the ground after 6 seconds of being thrown. And that is, actually, I feel like I should have subtracted 6 and -3, and it probably hits the ground at 9 seconds, but maybe maybe I'm just double guessing myself. And I remembered now that I also forgot to put part D in question 4. Wait a minute. That was question 3. Oh, sorry, that was question 3. So for question 4, we used GeoGebra to kind of map out these different points that were given. I think I forgot to put C. There's an E missing here. I forgot to put C in there. And I realized in GeoGebra, but I didn't change it on my on here. So the point, it does look like an exponential function because the growth is exponential. You can see the difference between A and B versus, B and C and C and D. It's definitely exponential growth. So for the equation, we were given to find A and B using f of x equals A times B x. We know that B is going to be the base of the exponential function. So given 0, it's really helpful because knowing that B is, or like knowing that x is 0, we know that y or A is 1.5. So I used 1.5 as A, plugged it into where we have x is 1. Or sorry, y is 4.07, and then solving for B, I was able to get the base number. And this is the equation that I came up with afterwards. And then we were also asked if it 100% matched the data, and then why might there be an error. So I felt like it did match the data. And then I feel like there could be an error maybe with calculators, and then maybe like the decimals, rounding up or down might be an issue. Mine came out pretty clean, so I'm not sure, but I think that is possibly potential for error. So that's all. Thank you so much.